All right, this is part 2 of 10.3, the shapes of distributions, and how do I determine the shape of a distribution using the data? It looks like we have a lot of ages. I don't even know what this is referring to yet, but these are the data I think we're going to be using in this table. It says the frequency, the number of times something happens. The frequency table shows the ages of people watching a comedy in a theater. So a comedy movie, I suppose. Display the data in a histogram. Histogram's got intervals and frequency. Describe the shape of the distribution. Well, everybody, I didn't want to have to fail in front of you creating this histogram, so I already did it. But just let's go over, make sure this makes sense. Like for instance, ages 22 to 25, I said that the frequency is about 12. Let's see if that's right. 22 to 25, yep, frequency is 12. That means that there were 12 people aged 22 to 25, including 22 and 25, that went into or were counted watching the comedy. And notice that all of these intervals are about the same size, right? So age 10, 11, 12, and 13. So that's 4 different years, right? And same thing with 14, 15, 16, 17, 18, 19, 20, 21, so on and so forth. So I created this. What do you notice about the distribution? Do you notice that most of the data are concentrated over here to the left? Are they little tiny kids? Or wait, not kids, I guess your guys' age. Are they younger people or are they older people? Oh, those older people like me. Oh, it's us. Ugh. So if most of the data are here to the right, even though there's this little tiny chiquito right there, if most of the data are to the right, then that means this is skewed left. Oh, I love skewed left distributions. All right, skewed left. I don't even know if that's supposed to be capitalized. Shh, don't tell anybody, I don't know. But this is skewed left, and that's all we have to say. The histogram is skewed left, which means most of the data are here to the right. Excellent. Let's go on to the last question. Let's get this done. We've got it. Hold on, let me scroll down there. You banging them. I think we're gonna need we're gonna need this. Well, it's already gone now. Okay, so what is a real world example? Well, this is a real world example. The histogram, wait, histograms, they have intervals and frequency, shows the ages of people watching an animated movie. Oh, versus a comedy. First, part A, describe the shape of the distribution. So let's describe the shape. We only have 3 different options, right? We have symmetric, skewed left, and skewed right. Okay, animated movie attendance. Okay, let's make sure that these intervals are the same. Yep, they're all about 4 years, right? And 10 to 13. Yep, that's the last one started with. Frequency is how many people were recorded in those age categories. Interesting. Where are most of the data centered? Are they in the younger ages or the older ages? The younger ages. And if most of the data is here to the left, that means this is skewed right. So it's like opposites, right? So skewed right. Okay. Now it says which movie has an older audience? Well, if this is skewed right, most of the data are to the left, which it's mostly younger people, right? And in the comedy that was up above, it was skewed left, which means most of the data were to the right. If most of the data were to the right for the comedy, that means most of the data were older, right? Older people. So which movie has an older audience? The comedy. And I'm going to actually explain why. Comedy. Which movie has an older audience? It was skewed. Whoa. Left. So most of the data. I know I'm going to run out of space. I don't even care. Most of the data, oh, I'm going below, was on the right side. which were Ayabuka. That was not how you spell were. This is probably such entertaining YouTube content right now. So hit subscribe, which were the older ages. All right, everybody. That's it for shapes of distributions. You're all amazing. Only 2 parts to this video. Pretty easy section. I hope you rock the homework. Have a good day.